Hey everybody, my name is Jason, also known as Pirate JC, and welcome to part 7 of the Mystery Demo Tutorial series. If you've been following along, then you know that this is the series where we're going step by step through the process of building a demo together, but I'm not telling you what it is that we're building. You're gonna have to find out as we go along. If you haven't already done so, please check the description down below to see some of the other videos in this series. We're gonna be picking up right where we left off from video number 6. And in fact, speaking of, down in the description down below, you can actually find a link to this playground, which is the exact state that we left off for video number 6. In the last video, we took our water caustics that we had made and projected them out of a light into this scene, over the sphere and the ground into this scene. Definitely went through a lot, but we're gonna go even deeper into creating this scene. But I mentioned in the last video that we're gonna need to dial in our caustic numbers at some point. And I thought now is as good a time as any to actually dive in and do that. So we're gonna go really fast, and I'm gonna go ahead and give you a whole bunch of numbers to kind of dial in the final positioning and kind of execution of what I think the best numbers are for kind of our caustics material, the kind of the pattern of it. Okay, so to do that, what we're gonna do is we're gonna go over to materials in the inspector, open that up and you'll see caustic material. You'll click that. We're gonna go ahead and drag this up a little bit here. And then we're gonna scroll down all the way into past configuration and you'll see all of the inputs. Now these are all of the inputs that we designed in the node material editor to say we wanna expose those to the inspector. Right? You remember that when we set those flags and we said, hey, we want these to be available in the inspector so that anytime you load that node material, we can actually dial them in very, very quickly right here. And then I'm going to show you how you can actually save that back to a new URL and then pull that URL back into here to save all of our changes. So let's go ahead and do that right now. We're gonna go super, super fast through this. So just bear with me. If you need to stop at any point to kind of catch up, not a problem at all. I'm gonna be running through this very, very quickly, okay? So our caustics power, we'll get started right away. We're gonna set that up to 0.8, okay? And don't worry, it's gonna change, the pattern's gonna change a lot. It's gonna darken, it's gonna brighten at different times. So we'll dial that right into 0.8. Our resolution is gonna be set to 7. And I'm gonna hit tab to go forward here, tab right to the next one. Okay, wave number 1, our amplitude high value is gonna be 0.3 and amplitude low value is gonna be 0.2. Our amplitude speed is gonna be 0.5. Are you scared yet with how fast we're going? Don't worry, you'll be able to catch up, it's not a problem. So a steepness high of 0.64, a steepness low of 0.2, a steepness speed of 3. A wavelength high of 2.5, a wavelength low of 1.5, a wavelength speed of 0.85, a wind direction high of negative 0.7, a wind direction low of negative 0.62. I went too fast for my own good. Wind direction speed of 1.13, and that is it for wave number 1. Okay, great. Let's open up a wave number 2. And we are going to give it an amplitude high value of, are you ready? We're gonna say 0.3, an amplitude low value of 0.15, an amplitude speed of 0.6, and a steepness high of 0.64, a steepness low of 0.32, a steepness speed of 1.15, a wavelength high of 4, wavelength low of 2, a wavelength speed of 0.3, a wind direction high of negative 0.9, a wind direction low of negative 1.1, and a wind direction speed of 0.65. And that is it for wave number 2. Okay, so let's go open up wave number 3 here. And we're going to take this value. Wave number 3 is going to start at 0.6 and a wave for the amplitude high, an amplitude low of 0.5. Amplitude speed of 0.57, steepness high of 0.64, steepness low of 0.4, and a steepness speed of 2. A wavelength high of 3.5, a wavelength low of 2, and a wavelength speed of 0.5. A wind direction high of 0.85, a wind direction low of 0.75, a wind direction speed of 0.65, and that is it for wave number 3. And now into wave number 4. We're going to start with an amplitude high value of, are you ready? This is going to be 0.3. Amplitude low value of 0.1. Amplitude speed value of 0.76. A steepness high of 0.64. A steepness low of 0.32. A steepness speed of 0.85. We're going to do a wavelength high of 3.75. A wavelength low of 2.5. We're going to do a wavelength speed of 0.7. A wind direction high of negative 0.13, a wind direction low of 0, and a wind direction speed change of 0.35. And that is it for wave number 4. We're going nice and fast through these. I hope you're able to keep up every step of the way. I'm kidding. I don't expect you to. We're going just blasting through this so that you have the numbers. Okay, an amplitude high value for wave number 5. Are you ready? 0.27. An amplitude low value 0.2. An amplitude speed of 0.33. A steepness high of 1. A steepness low of 0.2, lots of variation on that guy. A steepness speed of 2, a wavelength high of 10, a wavelength low of 6, a wavelength speed of 0.25, a wind direction high of 0.35, or wind direction low of 0.15, a wind direction speed of 4. Okay, and that is it for wave number 5. And finally, last but not least, we are into wave number 6. This is it. Here we go. Nice and fast. An amplitude high value of 0.65, an amplitude low value of 0.45, an amplitude speed of 1, a steepness high of 0.64, a steepness low of I can't see it, 0.24, a steepness speed of 0.8, a wavelength high of 13, a wavelength low of 0.5, that's huge variation, a wavelength speed of 0.25, a wind direction high of 0.75, a wind direction low of 0.65, and finally, last but not least, a wind direction speed of 0.82. We are done. Congratulations if you made that through that. That was my best impression of the fast-talking auctioneer type voice. And so there you go. That is a final looking caustics pattern. But now what we'd like to do is we'd actually like to save out those values so we don't ever have to type those out again, because I'm sure you don't want to relive that. If you haven't done so, go ahead and pause now. You can catch up, rewind, whatever you need to catch those values. And we're going to go ahead and start right now. Okay, great. We're back at it. What we're going to do is now scroll up. Okay, and we're going to scroll all the way up past all of our inputs until you see Node Material Editor. Under configuration, you say Node Material Editor. If we click that button, it will actually load a new window for us, and it will take a second, with all of our math. Does that look familiar to you? That's all of our math right there, with all of the new values for our node material, okay? Now, you'll notice that we're missing a button here. There is no button for save as a unique URL here. And the reason for that is there's actually no URL that we could show you what the result was if we gave you that button here. Okay, this is a separate instance based off of the playground, but there is a save button. So we're gonna go ahead and click that. Now, what happens when we click save is this actually just goes right to your downloads folder, okay? We'll show it in the folder here. So right in the downloads folder, we have the node material right there. So what we're going to do is we're going to open up a new tab. We can actually close this. We can close this. We've saved out that status. We're going to open up a new tab and we're going to go to a fresh node material editor. Okay. This is a brand new one. This is where we started from stage 1 in the first video. And now what we're going to do is we're going to go to this file load. Okay. And if we hit load, go to our downloads, we can actually load the state with all of the data, and there you can kind of see how it's looking, okay? That is fantastic. So now what we can do is notice what's back, save as a unique URL. And that's because we are actually in the standalone version of Node Material Editor, not the one that coincides with the playground. So let's go ahead and hit save as unique URL, and we're going to grab everything after the first hash here, okay? And we're gonna hit copy. We'll go back to our playground, and then what we're gonna do is we're gonna find where our caustics material is, which is right here, and we're actually going to replace that. We're gonna replace it with that number, and we're going to hit play. And hopefully we see the exact pattern now saved into a new node material session and making it all the way back to the playground. That's awesome. So we have an effective tool for being able to pass data between the two. You can save your state from a node material, a standalone session. You can load that into a playground, but you can also still get that information out back to a new URL if you want to parse it back in the playground. That's pretty cool that that exists. It's definitely something that we want to look at and see if we can make better in the future, but that is awesome that there's a full circle, full path to be able to go back and forth. Okay, at this point, you've probably guessed that we have a caustic-like pattern. We're projecting it out of a light onto some elements. You can probably guess that we're creating some type of an underwater type experience. And that's all I'll say. I don't want to lead the witness. But in order to do that, there's some more that we need to do here, okay? The first thing that I'd like to do is I'd like to not have generic background. I actually like to have tighter control over the background, okay? So we're gonna actually go create a cube, and rather than have it face outwards like a normal cube would, we're actually going to have it face inwards, okay? And that's pretty easy to do actually. So what we'll do is we'll go right under our debug layer where we're telling the code to show the inspector. And we're simply going to do a var, we'll call it a background cube, okay? And then we're gonna say new Babylon.mesh builder is what we're gonna use. And then there is a create box, and this is a method, okay? And what we're going to do here is we'll call it a background cube. And from here, it's going to want some parameters, some options, okay? So the first thing that we're gonna do is we're gonna give it a size of 60. We'll make it nice and big. And then we're going to give it a side orientation of 2. Side orientation of 1 means it faces out, the normals face out on the outside of the cube, which is what you'd expect. What we want to use it for is though we want the normals to face in, basically, right? So we want the opaque side of the face to be on the inside of the cube facing us. And so that's what that means. That's why we're doing that. Okay, and then finally over here, we're going to attach the scene. Okay, so let's go ahead and hit play on that. And now we've got a solid background. Now you'll notice that the caustics are actually showing through back there. Not a problem, because our next step is to actually go in and get rid of this face here. And we're actually gonna say, you know, our ground plane, we're just gonna make it bigger. We're gonna make it stretch, okay? We're gonna say, let's make it nice and big. We'll say 50. 50 by 50 for this ground plane. Okay, and we'll hit play. And now we've got a caustics pattern that's stretched out, starting to look a little bit more like an underwater type scene or experience. Hint, hint, nudge, nudge. Okay, so the next thing that I think we could do to add to this scene to make it feel a little bit more atmospheric is something very simple, but very, very elegant and adds a lot of style, which is to add fog to the scene. Okay, I'm gonna go back up to the top. I'm gonna put the fog right underneath the cube, and I'm going to say scene.fog, and we're going to do fog mode, and we're going to set that to Babylon.scene.fog mode, and we want linear, fog mode linear. And the reason for that is just so that we can have some nice tight control over our scene.fog start. Okay, and we're going to set that as a distance of 5. And then we'll do scene.fog end, and we're gonna give that a value of 25. And then let's do scene.fog color. And we're gonna give this a new Babylon.color3. And we'll give it values of 0.1, 0.08, and 0.25. Okay, and then finally we're going to say scene.fog density, and the density of this we're going to set to 0.1. And now if we hit play, now we have something that's really starting to feel atmospheric and definitely a little bit more underwater type feeling. That is amazing. I am excited about that. Already, just with a few simple things that we've done, have created a pretty cool looking atmospheric demo. Oh, but don't worry, there's still a lot more that's gonna happen here. In fact, the next thing that we're gonna do is gonna be pretty deep. Okay, we're gonna dive into something really, really deep actually. We're going to create Godrays. Godrays are the kind of common term for the light ray that you can see through, say, particulate like dust. If you've ever seen like light shining through a window and then there's dust in the air, you can actually kind of see what appears to be kind of a light ray. The same thing happens underwater. So we're going to do that. And my good friend Patrick Ryan has done an amazing chunk of work that we're going to replicate here to actually showcase exactly what it is that makes this experience so awesome. So we're going to be doing particles together, okay? And the particle system is something that is, it's really impressive what is being done with it. It's awesome in Babylon. But actually, to start, there's going to be a link down in the description below for this. Well, yeah, let's actually open up a new tab here. And I'm going to go ahead, you can just copy and paste this, but I'm going to go ahead and type this in. And so what I want to do is I'm going to grab this right from, we're going to say raw.github, githubusercontent.com/Patrick Ryan MS /Babylon.js textures /master/demos /underwater /assets /volumetric light.png. See how my typos were? Oh, we did it! Awesome! So Patrick has done this work of creating these very cool looking Godrays that he's put onto a sprite sheet for us that we're going to leverage in Babylon's particle system to be able to create these Godrays, okay? Now, I am going to warn you, this next part, we're going to go through a lot together. There is some density to it, but if you follow right along with me, you should be able to create something pretty amazing looking, okay? So to start off with a particle system, I think what we'll do is we'll go find our water shader here. And let's just go ahead and add some space. Oops, in the wrong spot. Let's add some space here. Yeah, I think that's fine. I think this will work. Okay, so in order to start, what we're going to do is we're going to create a new variable, and we're going to call it volumetric emitter. Okay, volumetric emitter. And we're going to do new Babylon.abstract mesh. Now the abstract mesh wants a name. We'll call it volumetric emitter. And then it also wants to be attached to the scene. The next thing that we're going to do is we're going to create a variable called number of cells. Okay. And then the next thing that we're going to do is we're going to create a function that basically sets up our animation sheet. It sets up those sprites ready for us to use in the particle system. Okay, so this is going to be a lot that we go through here, but again, hopefully something that definitely gives you an idea of some of the power behind what's possible with Babylon's particle system. Okay, all right, so let's go ahead and say var setup animation sheet. Now this is going to be a function. And it's going to be asking for a good number of variables, okay? It's going to want, first and foremost, one called system, texture, width, height, number of sprites in the width, number of sprites in the height, animation speed, and value for is random. Okay. Now, inside this, the first thing that we're going to do is we're going to assign the animation parameters inside this function. Okay. So we're going to say system.isAnimationSheet enabled, and we're going to set that to true. Right. Next thing, system.particleTexture is equal to new Babylon.texture right there. And this is going to be texture scene. And then we're going to set the no map to false, and invert Y will set to false. And then the sampling mode is going to be Babylon.texture.trilinear sampling mode. Okay, and that is it for that one. So next, enter. Next, we're going to do system dot particle texture dot wrap u is equal to Babylon.texture dot clamp address mode. Okay. And then you can imagine we'll copy and paste, and we'll do the same thing. Shift end copy, go down, paste, and we'll do the same thing for wrap v. This is we're talking about UVs for sprite sheets, right? U and V are the two coordinates for 2D. Okay, and so now we're going to say system dot sprite cell width, and that is going to be width, the variable that we're passing in for width, divided by the variable that we're passing in, or the value we're passing in for sprites, num sprites height. I can type, there we go. Okay, and then system dot, let's scroll down so we can see a little easier. System dot sprite cell height is going to equal height divided by num sprites height. I did that wrong. I did that wrong. This should be width. Width divided by num sprites width. Okay, sorry about that. There we go. And then next we're going to say the number of cells is going to be equal to the number of sprites width multiplied by the number of sprites height. System, this is the next line, dot start sprite cell ID is going to be 0. We're going to tell it where to start. System dot end sprite cell ID is going to be set to the number of cells minus 1. System dot sprite cell change speed is going to be set to animation speed. And then system dot sprite random start cell we'll say is set to the value of what's being passed into is random. And then finally, last thing for our function here is system.update speed is equal to 1/30. Okay, so now we have a setup function. This is great. A setup function for starting the animation sheet. So to take those sprites, if we pass in the information we need, and it'll set everything up for us ready for the particle system because of the work that we did here. Okay, so now the next step is to actually go through and create the particle system itself. Okay, now this is, we're going to type in a lot just like we just did, but just follow right along. And again, hopefully you can kind of see exactly how powerful this can be. All right. So the particle system, we'll say var, volumetric system instead of emitter. We're going to do system this time. And then we're going to say, you're going to be new Babylon.particle system. There it is, particle system. And then we're going to give it a name. We'll say volumetric system. And next, it wants a capacity. What's the maximum number of particles we should have? We're going to say 100. And then it wants to be attached to the scene. Custom effect, we'll say nothing. And then is the animation sheet enabled? That's a Boolean. And of course, because we're using a sprite sheet, we want to say true to that one. Okay, next we want to call our function, set up animation sheet, and of course we want to pass it a lot of information. So the first thing we want to do is it's asking for a system. So we want to pass in this new volumetric system that we just created here, right? That's a brand new system that's being pumped right into this system here, okay? The system variable. So volumetric system, then next it wants the texture. Okay, so now we're going to grab the URL, our Godrays here from Patrick. Thank you so much, Patrick, for giving us all this awesome power. We'll go back here and we will paste it right into this function. So a lot more that we're going to do here. We're going to say it now wants the width. So we'll say 1024. We'll make this a 1K. Oops, we'll make this 1K. 1024 by 1024. And then the number of sprites in width is, Can you guess how many there are in width? There are 4 different sprites here. So we'll go 4 for width. And in height, 4 comma. In height, we only have 1. And then for animation speed, we're going to set that to 0. And is random, we're going to say, yes, we want that to be random. Okay, fantastic. So what is next? Let's keep scrolling up, give ourselves some room. Next, we're going to say our volumetric system dot emitter, and we're going to say we want that to be located at the volumetric emitter dot position. Okay. Next, then we're going to create a box emitter. And we're going to say volumetric system dot create box emitter. And here we're going to say the first thing that it wants, let's take a look, create box emitter. First thing that it wants is a direction. In fact, it actually wants several directions. So the way that we're going to do this is we'll start by saying new Babylon.vector3. This vector3 is going to have values of -1, 0, and 0. The next direction, new Babylon.vector3, will have values of 1, 0, 0. And then the next thing we want to do is say new Babylon.vector3, because yes, again, we want another direction here. And this one is going to be -5. It's going to be 5, and then it's going to be -3. Okay, and then let's see. What else does it want? It wants new balance. Oh, that's it. Nope, I need one more. I need one more. I need one more. Okay, new Babylon vector3, and this is values of 5, 5, and 3. Yep. Okay. Perfect. So I have 4 different directions. That's right. I'm closing up the parens. That is correct. Okay, that's the box emitter. So now we're going to take that box emitter and we're going to say I want to have a radius range of 0. I now want to go back to the volumetric system. Okay, so the volumetric system, of course, is the system that we created up here. That's actually basically the thing that's, it's the entire particle system. That is the particle system. And so we're going to say volumetric system, and we're going to give this a min initial rotation of 0. Okay. We're going to give it the volumetric system dot max initial rotation of 0, because we don't want it rotated all over the place. We have it designed by Patrick the way that we want it in the sprite sheet, which is awesome. Volumetric system dot min scale x. Min scale x we're going to set to 6, and then we'll do volumetric system dot max scale x, and we're going to set that to 10. And then volumetric system dot min scale y, and we'll set that to 30. And then volumetric system dot min scale max scale, sorry, dot max scale y, and we're going to set that to 50. Okay, let's keep going here. Volumetric system. I know this is a lot. Don't worry. Just follow right along. Just giving you kind of a broad overview. We're doing it step by step, but a broad overview of the power of what's possible with the particle system because of sprites. So just follow right along. Volumetric system. And so we want min life. Yep, min lifetime. We're going to set that to 6. And then, of course, volumetric system dot max lifetime, and that's going to be set to 9. Let's go ahead and scroll up so we can see a little bit easier. Okay, volumetric system dot emit rate, there it is, and we want that to be 15. volumetric system dot min emit power. Just dialing in all these different properties for the volumetric system. Min emit power is going to be 0.05. Volumetric system dot max emit power. That's going to be set to 0.1. Okay, getting close. I think we only have a couple lines left here, and then we're going to hit play and see something pretty amazing. Volumetric system, we have the max emit power, so now we're going to do min size. Okay, so the min size is going to be set to 0.1, and volumetric system dot max size, and we're going to set that to 0.2. And then let's add now the color gradients. Okay, so volumetric system dot add color gradient, not remap gradient, we want add color gradient. There we go. And here we want to say at 0.0, we want to do a new Babylon.color4, color4, and we're going to give that drumroll 0, 0, 0, 0. Okay, did I say out loud the correct number of zeros? And now volumetric system.add color gradient, and we're going to do, this one is going to be at 0.5 on the gradient, and we're going to say new Babylon.color4, and our values here are going to be 0.25, 0.25, 0.3, and 0.2. Okay, and then one more gradient, add color. What did I do wrong? Oh, yeah. System.add color gradient. There we go. And then this one's going to be at 0.1 on the gradient. We're going to say new Babylon.color4. There we go. And the color 4 is going to have values of 0, 0, 0, 0. Okay, there we go. Last thing that we need for the particles, the very last thing is to say volumetric system dot start it up. And if we have done this correctly, when we hit play, we're going to see something truly spectacular that adds a ton to this scene. I did it wrong. I'm back. I do apologize. That took me a minute to actually troubleshoot. I don't like to cut in the middle of these videos, but had to that time to actually understand what's going on. Congratulations if you already figured it out. I made 4 pretty bonehead mistakes. Let me point them out to you now so you can laugh in my misery along with me. The first, let's scroll up to the top here. When we're doing our setup animation sheet, you'll notice that I have this system.sprite cell width equals width divided by num sprites width. And then right underneath it, I just completely made a bonehead move and put something random in there. And so what this should be is sprite cell height. That's the first bonehead mistake. This one, potentially the most embarrassing of all of them, is a simple typo. So we can call that system.update speed. And then this is also a pretty bonehead move as well. Here, when we're actually building out the particle system, create box emitter, I just was moving too fast and forgot to close out that paren. And then last but not least, I actually did forget one pretty important thing for kind of the look that we want here. So I'm actually going to add one final line, which I neglected to add, which is volumetric system dot blend mode, and then we're going to set that to Babylon dot particle system dot blend mode add. We're going to set it to add just to make sure everything really looks as good as it can possibly be. And now, as promised, when we actually hit play, we have an amazing scene with Godrays there on the top. Thank you so much to Patrick Ryan for getting this all up and working, showing us how it works so I could share a little bit with you. I apologize about the bonehead moves. Our scene is coming together. Ladies and gentlemen, it is starting to look like a demo. We're getting there. I hope you're as excited about this as I am. The next videos are going to really start to illuminate where this is headed. Only 2 more left in our series. Thank you so much for watching and checking out this video and the other videos in this series. If you have not had a chance to do so, I would ask you to consider subscribing to this channel so you don't miss any future updates. Thank you so much for checking it out, and we'll see you in the next one.